Yeah.
If you walked out to your yard right now, like today, and just dug a hole maybe 6 feet deep, you would
Okay.
actually find a hidden thermal battery. And according to the sources we're looking at today, tapping into that specific layer of dirt just a few feet down could act as a permanent cheat code, to slash your home energy bills. Like operating with efficiencies pushing past 500%.
Yeah, and it is entirely counterintuitive, right? I
Yeah.
mean, most of us just look at heating and cooling as this brute force mechanical problem. We basically just buy a bigger metal box to fight the outside air.
Yeah.
But the reality is, it's far more elegant than that. It relies heavily on physics and geology rather than just, raw electricity.
It is exactly what we are getting into today. So, welcome to the deep dive. We are on a mission to basically uncover the hidden science, the really surprising economics, and the extreme weather engineering behind how we actually keep our living spaces habitable. And we're using two highly specific kind of boots on the ground sources to do it today. So first we have the technical and service materials from Hartzell's Heat and Air. That's a 15-year-old employee-owned local business out in central Oklahoma. And then paired with that, we have the April 2026 utility remate documents straight from the CKEnergy Electric Cooperative.
Yeah, and I know those might sound like really hyper-local sources, but they actually offer a perfect microcosm for this stuff. I mean, central Oklahoma is basically the ultimate crucible for HVAC technology.
Oh, for sure.
The extremes of that specific climate force engineers to just, well, to completely throw out the standard playbook and get incredibly precise.
Okay, let's unpack this because to understand why a local utility cooperative is throwing just massive amounts of money at a geological solution, we kind of have to look at the actual environment they're battling out there. It's not just that it gets hot.
Yeah.
It is the sheer volatility of it.
Precisely. I mean, let's just look at the raw thermodynamics of a central Oklahoma summer. You are dealing with temperatures consistently hitting like 100 to 110 degrees Fahrenheit.
Right.
But the real issue is that this massive heat is paired with relative humidity that frequently just sits above 80%.
Ugh. So breathing the air out there just feels like you're drinking it.
Exactly, yeah. And that combination creates a massive thermodynamic challenge. Like, in engineering terms, we basically have to address two entirely different energy loads at the same time. You've got the sensible load.
Which is what exactly?
That's the raw temperature, like the actual heat you could physically feel on your skin. But then you have the latent load, which is the humidity, the actual physical mass of water vapor suspended in the air.
Oh, okay. So if you take like a top-of-the-line air conditioner that was engineered for a totally dry, arid climate like Phoenix or Denver, and you drop that exact same unit into a house in Kingfisher, Oklahoma, it's going to struggle, right?
Oh, it will fail completely.
Because it might be great at dropping the temperature, but it wasn't built to, like, wring out that heady moisture.
Exactly. Removing water from the air, what we call dealing with the latent heat of condensation, requires an enormous amount of energy. The air actually has to pass over the cooling coil slowly enough, and that coil has to be cold enough for that water vapor to actually reach its dew point, to condense into liquid and drain away.
It's kind of like, okay, think of a bouncer at a crowded club trying to do two totally different jobs simultaneously. On one hand, he's trying to physically shove the rowdy heat out the front door.
Right.
But at the exact same time, he's like wrestling with this invisible heavy humidity that's trying to sneak past the velvet rope. If he only kicks out the heat, the club is still just a miserable, sticky place to be.
That is a perfect analogy. And we really can't forget the winter whiplash either, because central Oklahoma is not a tropical zone. Ground temperatures there can drop so rapidly during a cold snap that a standard, air source heat pump functionally just gives up.
Wait, let's break down how that happens. Because a standard heat pump doesn't actually burn fuel, right? It just extracts ambient heat from the outside air and moves it inside your house. But, I mean, how do you extract heat from air that is already sitting below freezing?
Well, scientifically, even cold air contains some thermal energy.
Really?
Yeah. The heat pump uses a liquid refrigerant that boils at an extremely low temperature, so it evaporates. It absorbs whatever trace amount of heat exists in that freezing outside air, and then a compressor physically squeezes that gas, right?
Yeah.
It concentrates the heat until it's actually warm enough to blow into your home.
Okay, but as the outside temperature drops to near zero?
Exactly. There's just less and less heat out there to scavenge. So the compressor has to work twice as hard to get basically half the result, and its efficiency just plummets.
Man, so the climate there is just actively punishing the equipment summer and winter. Given that my immediate instinct, and honestly, probably the instinct of anyone living through a 110-degree heat wave, is to just go out and buy the absolute biggest, most powerful air conditioning unit possible. Like, just brute force the problem.
Yeah, and that leads us directly to the rule of thumb fallacy, because that instinct is actually the most common and honestly the most disastrous mistake that both contractors and homeowners make.
Wait, really? A bigger unit is worse?
Yes. Historically, a technician might just measure the square footage of your home and apply this blanket formula. Like, oh, you have 2,000 square feet. You need a 4-ton air conditioner.
Well, yeah, if the heat is that intense, having a bigger, more powerful machine that cools the house down incredibly fast sounds like exactly what you'd want.
It definitely sounds ideal until you understand the physics of what we call short cycling.
Yeah.
So remember the latent load we talked about earlier, the heavy water vapor in the air.
The club bouncer wrestling the humidity, right?
Exactly. If you install an oversized, hyper-powerful system, it drops the sensible temperature, the actual heat of the house, incredibly fast. I mean, the thermostat reads that target temperature in like 10 minutes and just shuts the whole system off.
Ah, I see the problem. The coil gets super cold. It drops the air temperature down to 70 degrees, but it shuts off before it actually has the time to condense and drain any of the moisture?
Exactly. The latent load is left completely untouched. And the result is this phenomenon that HVAC technicians call cold and clammy.
Oh, that sounds awful.
It is. You are literally shivering, but your skin still feels damp. And even worse, over time, that trapped indoor moisture actually feeds mold growth inside your drywall and your ductwork.
Plus, there's more.
Yeah. An oversized compressor requires these massive surges of electricity to turn on and off so rapidly, which actually wears out the mechanical components years before their time.
So let me get this straight. You pay a premium for a much bigger, more expensive machine, and your reward is a damp, moldy house and a burned-out compressor.
That is exactly right.
Wow. So if the basic square footage math is essentially a trap, how does a company like Hartzell's actually figure out what size a house really needs?
So they rely on the industry's strict engineering standard. It's called the manual J-load calculation. And our sources point out that Hartzell specifically performs this exact calculation before any replacement.
So they aren't just walking around with a tape measure.
No, they completely abandon the tape measure approach. Instead, they calculate the actual thermal resistance, what we call the R value, of your specific exterior walls and your attic insulation.
And they also have to account for the windows, right? I mean, a massive wall of single-pane glass facing the west sun is basically a giant magnifying glass just roasting your living room at 4 p.m.
Oh, absolutely. The manual J factors in the solar heat gain coefficient of all the windows, their exact orientation to the sun, and even the infiltration rate of the actual building envelope.
The infiltration rate, like drafts.
Yeah, they might even use a blower door test to measure exactly how much outside air actually leaks in through the tiny cracks in your framing. Basically, it takes local historical weather data and maps it against the specific real-world physics of your actual house.
Okay, so you run the manual J. You get the absolute perfect, mathematically verified size for your air conditioner. But even then, aren't we still kind of fighting a losing battle? Because you're still asking a metal box sitting outside in a 110-degree parking lot to somehow radiate heat away into air that is literally already boiling. Like, it's fundamentally fighting basic thermodynamics.
You're right. It is inherently inefficient. You're basically trying to dump thermal energy into an environment that absolutely refuses to accept it.
Well, here's where it gets really interesting. If the outside air is basically the enemy here, the ultimate hack is to just, stop using the outside air entirely.
Exactly. We shift our entire focus from the air to the ground. We exploit the Earth's thermal mass.
Okay, let's really get into the geology of this hidden battery. What is actually happening 6 to 8 feet under the soil in central Oklahoma?
So at that specific depth, the Earth is completely insulated from the chaotic weather up above. It acts as an infinite, stable thermal mass.
Meaning the temperature doesn't really change.
Right. It doesn't matter if there's a 108-degree heat wave raging in August or if there's a brutal 14-degree ice storm paralyzing the state in January. The dirt at that specific depth maintains a constant, completely stable temperature of roughly 59 to 62 degrees Fahrenheit all year round.
Wow. So a geothermal system like a ground source heat pump, it just taps directly into that stable 60 degrees. Instead of that loud metal fan screaming in your side yard, you bury these high-density polyethylene pipes right in the ground and circulate a liquid through them, right? Like water or some kind of eco-friendly antifreeze.
Exactly. The liquid absorbs the heat from your hot living room in the summer, travels underground through those pipes, and just effortlessly dumps that heat into the cool 60-degree Earth. The Earth is basically acting as an infinite heat sink. Then the cooled liquid comes back inside the house, and the cycle repeats.
And in the winter, the entire mechanism physically flips. The system extracts that steady 60-degree warmth from the Earth, compresses it to amplify the heat, and warms your home. But the part that really blows my mind is how the machine actually reverses itself.
Oh, it is a brilliant piece of mechanical engineering. It's called the reversing valve.
How does it work?
It's basically a four-way sliding valve inside the heat pump that literally redirects the entire flow of the hot, high-pressure refrigerant gas. With just a single electrical signal, it changes the indoor coil from being an evaporator that absorbs heat to a condenser that releases heat.
And because it's starting with a warm baseline of 60 degrees instead of, freezing outdoor air, the efficiency just goes completely off the charts. Like, we are talking about a coefficient of performance that yields 300 to 500% efficiency.
Yes.
You're putting 1 unit of electricity in and getting up to 5 units of actual heating or cooling out. That's wild.
It is, because, again, you are not actually creating heat. You are merely operating a pump to move heat that the Earth has already naturally provided.
Okay, but I have to play the skeptic here for a minute.
Sure.
I can't just wave a magic wand and bury a massive thermal loop in my backyard. I mean, tearing up a residential yard to dig deep trenches, dodging local utility lines, tree roots, destroying my landscaping, that all sounds astronomically expensive. If this is a 500% efficient sheet code that lasts for 50 years, the barrier to entry's got to be the installation cost.
Well, you've isolated the exact bottleneck. The underground loop is a serious civil engineering project. The initial capital required to physically put those pipes in the ground is definitely substantial.
So how is any normal homeowner actually affording this? I know our sources show CKEnergy is throwing money at it, but why?
So the April 2026 documents from the CKEnergy Electric Cooperative completely alter the financial reality of this. For residents living in their 10-county territory, which, by the way, heavily overlaps with Hartzell's actual service footprint, the utility is offering massive subsidies.
How massive?
Specifically, a $2,000 per ton rebate for new geothermal installations and retrofits.
Wait, hold on. Per ton. What does physical weight have to do with cooling air?
Oh, it is a fascinating historical holdover. So before mechanical air conditioning was even invented, people cooled large buildings using literal massive blocks of ice that they harvested from frozen lakes in the winter.
Wait, seriously, so a ton of air conditioning is quite literally based on a ton of actual ice?
Exactly. Early engineers had to calculate the exact amount of thermal energy required to melt a single 1-ton block of solid ice over a 24-hour period.
That's amazing.
And that math comes out to 12,000 British thermal units, or BTUs, per hour. So today, when we say a typical home needs a 3-ton system, we literally mean it requires the cooling power of melting 3 tons of ice every single day.
Oh, that makes so much sense now. It's just a thermal conversion rate from the 1800s. So at 3 tons, CKEnergy is basically writing you a $6,000 check right off the bat.
Yes. And they will actually rebate up to $24,000 for a really large 12-ton residential system.
Okay, now let's use some deductive reasoning here. A utility company's entire business model is to sell electricity, right? Why would they voluntarily give away up to $24,000 to help me permanently buy less of their actual product? There has to be some larger economic motivation at play.
You're right, there is. And it all comes down to the nightmare of what the industry calls peaker plants.
Peaker plant.
Right. An electric grid must instantly match its supply to whatever the demand is. On a mild, breezy spring day, the grid just relies on its efficient, cheap, baseline power plants.
All right.
But on a 110-degree August afternoon, when hundreds of thousands of horribly inefficient air source AC units all kick on at the exact same time, the power demand just skyrockets.
And if the utility company can't meet that massive spike in demand, the grid collapses and we get rolling blackouts.
Exactly. So to prevent that, utilities are forced to build and maintain standby power plants, these peaker plants. And they're incredibly expensive to operate. They often burn natural gas or diesel, and they might only run for like 50 hours the entire year just to handle those few extreme summer spikes.
Wow, just sitting idle the rest of the time.
Right. And the wholesale cost of generating electricity during those peak hours is just astronomical.
Ah, I see. So paying me $6,000 to bury a geothermal loop in my yard shaves off a massive portion of my home's actual peak demand. If they can get a few thousand homes to do this, they avoid spending hundreds of millions of dollars building and firing up a brand new peaker plant.
Exactly. It is vastly cheaper for the cooperative to just subsidize your geothermal loop than it is to upgrade their entire grid infrastructure to handle the strain of conventional air conditioners.
Okay, so covering the upfront cost is great, but that's really just prong one, right? Because if I'm a homeowner, that big rebate doesn't actually lower my monthly electric bill directly if the system is still using some power. The utility must have a way to incentivize the actual daily usage too.
They do, and that is prong two of their approach, rate 46.
Rate 46?
Yeah. CKEnergy offers a specific, heavily reduced electricity rate exclusively for their geothermal customers. Because your system is actively stabilizing their grid year-round, you pay less per kilowatt hour, period. And over the 50-year lifespan of that underground loop, that compounds into immense savings. And then you add in the third prong, which is a 6% low-interest loan offered directly by the cooperative to cover whatever cost is left after the rebate, and the math completely flips in favor of the homeowner.
So let me get this straight. CKEnergy is willing to hand you the capital to bury these pipes, give you a drastically reduced energy rate for decades, and then fully finance whatever's left over.
That's right.
But here is the critical failure point I'm seeing. If the actual person digging the hole in your yard miscalculates the thermal conductivity of your specific soil, that amazing 50-year investment immediately becomes a permanent liability. I mean, who is actually qualified to install this kind of tech?
Well, this is exactly where we look at the operators detailed in the Hartzell's heat and air materials. You have Dave Hartzell, who has 45 years of HVAC experience, and his daughter Shelby, who runs the operations. They are employee-owned, they've been based in Kingfisher for over 15 years, and they are heavily, heavily credentialed.
Let's talk about that soil calculation part, because you can't just guess how the dirt is going to absorb the heat, right?
You absolutely cannot guess. The thermal conductivity of dense clay is vastly different from loose sand or solid rock. If an installer miscalculates the soil type and they bury a loop that is too small for your home's heat load, the ground directly around those pipes will eventually saturate.
Saturate, like it can't hold any more heat.
Exactly. It's like trying to plant a massive, incredibly thirsty oak tree in a tiny little terracotta pot. The immediate environment simply cannot sustain what the system is asking of it, and the system's efficiency just plummets.
And kind of addressing my earlier friction about totally tearing up the yard, I assume a skilled installer isn't just taking a giant backhoe to my prized rose bushes, right?
That is where the actual engineering comes in. Depending on the size of your lot, they can actually drill vertical boreholes going hundreds of feet straight down, which totally preserves the surface landscaping rather than digging massive horizontal trenches everywhere.
Oh, that makes way more sense.
Yeah, but they have to backfill those deep holes with a highly specialized thermal grout to ensure the plastic pipes make perfect thermal contact with the earth all the way down.
Which really explains why Dave Hartzell's specific credentials matter so much here. The source actually highlights his IGACE HPA accreditation. That's the International Ground Source Heat Pump Association. It's basically the gold standard for engineering these loops correctly. And he pairs that with a NATE certification, which is the highest hands-on technical standard in the entire HVAC industry.
Exactly. He is treating the installation as a strict engineering discipline. And that is backed up by an upfront pricing model that reflects total transparency for the customer.
Yeah, that transparency is huge. I mean, there's really nothing worse than the anxiety of an unknown invoice looming over you when a technician shows up at your house. Hartzell's uses a flat $99 dispatch fee, a $111 diagnostic fee, which is actually credited back to you if you move forward with the repair, and a flat $229 for a tune-up. Like, absolutely no hidden stacking fees.
Right. And in a smaller community like Kingfisher, an employee-owned business really survives entirely on trust. Sponsoring the local soccer teams or showing up for the Masons' pancake breakfast means they're looking their customers right in the eye every single weekend. The accountability there is absolute.
So bringing this all together, what does this all mean for you, the listener? We've navigated the complicated thermodynamics of extreme weather, and we explained exactly why your house feels completely cold and clammy when an oversized system short cycles.
Yep.
We've broken down the manual J-load calculations, explored the totally wild history of measuring cooling in literal tons of ice, and we've unpacked how the actual dirt beneath your lawn offers a permanent 500% efficiency upgrade. And we've seen how local utilities and highly credentialed local professionals are making that transition financially viable today. So this deep dive is really an invitation for you to audit your own home's energy footprint. Are you still relying on those brute force mechanical systems that are basically fighting a losing battle against the outside air? Or is it maybe time to look at the real engineering right under your feet?
And just to expand on that for a second, I'd ask you to consider the broader implications beyond just a single residential lot.
What do you mean?
Well, if a single backyard can act as a permanent, high-efficiency thermal battery lasting half a century, imagine the impact of actually scaling this up,
Oh, wow.
right? What if entire new suburban developments or even city blocks were planned from the ground up to share a massive, interconnected geothermal network? We could drastically reduce our reliance on those expensive peaker plants overnight. The dirt beneath our feet might literally be the most powerful, untapped grid of the future.
Now, that is an idea that fundamentally changes how we view the ground we walk on every single day. So, the next time your air conditioner kicks on and you hear it just screaming against the summer heat, wonder if it isn't time to tap into that hidden battery. Thanks for taking this deep dive with us. See you next time.